What's up, geeks, and welcome to the channel. Today, we're kicking off a brand new series on Apache Kafka. But before we dive into the code, we really need to wrap our heads around what Kafka actually is and why everyone is using it. At its core, Apache Kafka is a distributed event streaming platform. Think of it as the backbone for real-time data pipelines and applications that need to react to information the second it happens. It follows a publish-subscribe model. You have producers that send data into topics and consumers that sit on the other side and read from those topics. Kafka doesn't just run on one machine, it runs on clusters made of brokers. A broker is basically a server responsible for storing your messages and serving them out. They work together to make sure the system is both scalable and fault-tolerant. If one server hits a snag, the others have your back. Now, for a cluster to work, someone needs to coordinate all these brokers. This is where things get interesting depending on which version you're using. Traditionally, Kafka relied on Zookeeper, but if you're using Kafka 4 or newer, Zookeeper is officially gone, replaced by something called KRaft. KRaft is much more streamlined because it handles all that coordination and metadata directly inside Kafka itself. To make sense of this, imagine Kafka as a massive, busy post office. Each broker is like a mailbox where letters or messages are dropped off and picked up. But to keep things running smoothly and make sure no mailbox gets overwhelmed, you need a manager. That's the postmaster. In older setups, Zookeeper was like an outside contractor hired to be the postmaster. In modern setups with KRaft, the postmaster is now an internal employee. They don't handle the letters themselves, but they keep the records of who is in charge of what and how to reroute mail if a mailbox goes down. You'll see Kafka used everywhere: real-time analytics, logging systems, microservice communication, you name it. Basically, if your system needs to react to data as it arrives, Kafka is the engine for the job. Let's get this running on our local machines using Docker Compose. Depending on your project's version, your YAML file will look a little different. If you're working with a version older than 4.0, your YAML will define two services, Zookeeper and Kafka. Zookeeper usually hangs out on port 2181 and Kafka depends on it to start up, running on its standard port 9092. You'll have to include environment variables as well, so the broker knows how to talk to Zookeeper. But if you're moving to Kafka 4.0 and up, your YAML gets way simpler. You only need one service, Kafka in KRaft mode. You still use port 9092 for your data, but Kafka handles its own metadata internally. It's a much cleaner setup. Okay, once your file is ready, just run docker-compose up and your environment is live. By the way, if you need a refresher on Docker, I've got a full course linked in the card above. Now, here's the best part. The Java code stays exactly the same regardless of whether you're using Zookeeper or KRaft. To start, head over to Spring Initializer. Pick Java, choose Maven or Gradle, and grab the latest stable Spring Boot version. You'll need two dependencies, Spring Web for your REST endpoints and Spring for Apache Kafka to bridge the two worlds. Import that into your IDE and we're ready to roll. First up, we configure our YAML application file. We'll define the Bootstrap server's address, which is just our local host 9092, and set a group ID so our consumers can work together as a team. For the producer, we'll create a configuration class to register a producer factory and a Kafka template. Inside that factory, we set up a map of configurations. This tells the producer where the brokers are and defines the serializers for our keys and values. Kafka only understands bytes, not Java objects. So, we use serializers to translate our data. We are using string for now, but in the real world, you might use JSON or Avro here. The Kafka template is what we actually use in our code to push messages to a topic. It's a clean, high-level tool that does all the heavy lifting for us. To use it, we'll make a simple message producer class, inject that template, and write a method that takes a topic and a message and sends it off. On the consumer side, we do something similar. We need a configuration class for a consumer factory and a listener container factory. Here, we use deserializers to turn those bytes back into readable Java strings. The listener container factory is what actually runs in the background, constantly checking for new messages. To actually grab those messages, we create a consumer component and use the Kafka listener annotation. Whenever a message hits your topic, this method automatically triggers and prints the data to your console. Finally, let's test it. We'll build a quick controller with an endpoint that takes a message as a request parameter. When we hit that endpoint, it calls our producer, sends the message to Kafka, and you should see your consumer pick it up and log it almost instantly. To do that, just start your Docker container, run the Spring Boot app, and fire off a request. If you see your message pop up in the logs, you're officially up and running with Kafka. So that covers the basics: theory, local setup with either Zookeeper or KRaft, and a full Spring Boot implementation. This is the foundation for building some seriously powerful event-driven systems. Let me know in the comments if you want us to dive into more advanced stuff like partitions, offsets, or scaling consumers. And that's it for this video. I hope it was helpful. If you learned something new today, hitting the like button and subscribing really helps the channel out. Thanks for watching, take care, and I'll see you in the next one.